All right, so let's talk about bubble sort. What is bubble sort? Uh, what is the complexity of it? And let's write a program using bubble sort. So, in order to know bubble sort, let's just search it on the web. Go to the Wikipedia page, and yeah, let's just read it out. So, bubble sort, sometimes referred to as sinking sort, is a simple sorting algorithm that repeatedly steps through the input list element by element, comparing the current element with the one after it, swapping their values if needed. So what it actually means is that uh, let's say we have this example. So we have an unsorted array which has inputs 5, 1, 4 to 8. So if we do bubble sort here, what it will do is it will compare this element and this element, and it will like compare which one is the smallest or largest. So it compares which one is the largest. So if 5 is the largest, it will swap 5 here and pass 1 here. So again, then it will do 5, 4, 5 and 4. It will compare 5 and 4 and swap them because 5 is greater than 4. So it will swap 5 to the right hand side and 4 will come to the left hand side. Similarly, it will do the same here. Uh, we have 5 and 2 now. So it will swap 5 to the right hand side because 5 is greater than 2. Uh, so the input becomes, so the array actually becomes 1, 4, 2, 5, 8, and then again it compares between 5 and 8, but now it's just sorted because 8 is larger than 5, 8 is greater than 5, so basically uh, 5 won't swap there, 5 will stay where at the current index, which is 0, 1, 2, 3 at the third index. So this is how it got sorted. Like it was we did bubble sort once, and this is what we got. So the largest two elements in the array are in the last part of the index, which makes sense. So now in the second pass we will do, it's 1, 4, 2, 5, 8. So now we will do 1, 4, 2. So we will compare between 1, 4, 2, 5, 8, and we will compare these two. So it's sorted because one is smaller. So now we will compare 4 and 2. So 2 will come here and 4 will go there because 2 is smaller than 4, and vice versa. Uh, and we can go like, then it will compare 4 and 5, but it's the same. So as you can see here, it says now the array is already sorted, but the algorithm does not know if it is completed. The algorithm needs one additional whole pass without any swap to know it's sorted. So basically, uh, here the algorithm is sorted, but now the algorithm doesn't know if it's sorted or not. So what it will do is it will swap it again just in order to confirm and then break the case. So 1, 2, 4, 8. So it again does the same steps repeatedly, and then it uh, confirms that yeah, it's completed. So talking about the complexity, bubble sort has worse complexity uh, because it's bubble sort is pretty bad during large inputs. In so when comparing or when sorting large data, we use mostly quick sort or heap sort, something like that. So yeah, as you can see, bubble sort has a worst case and average complexity of big O and square. So yeah, that's how it goes. And now let's write a Python program to actually understand this thing. So let's do a sort.py. So what we can do is here, uh, let's name an let's write a function called bubble and then pass an array. Then what we can do here is take the length of the array. Let's take a number and take the length of the array, right? Then let's take a for loop. Let's for in range, and let's keep it till number. So hmm, go like this. Yeah, let's mm, give a case which is array sorted. Let's give it true. Let's keep it by default as true value. Then let's take another, j. Yeah, let's take j. Uh, let's give the range as number minus I minus 1. And now you might be wondering why we gave this line, right? Uh, so let's see why we gave this, right? Okay, so let's see why this number, right? Why this range, basically number minus I minus 1, right? So you see, uh, whenever we make a comparison, right? Uh, all right, let's just take another example. Let's just take, for example, 3, 2, 1, uh, okay, 3, 2, okay, let's do 5, 2, 1, 3, 4, right? So this is the number, this is the unsorted array which we have to sort. So we have performed, let's suppose bubble sort, and then this array becomes like uh, this, right? Uh, so it becomes 2, 1, 3, 4, 5. So what actually happened was, during our first sorting, what happened was the largest element, which is 5 here. The largest element is 5 here. So 5 went to the last index, which should be the case, right? So now we don't have to, the next time we sort this unsorted array, we don't have to count 5 because it is already sorted and it's present in the last array. So we don't have to do that. So we just, uh, you know, we just don't we just ignore this index, and we just take the range from 0, 1, 2, 3 to this index. So that is why, for example, if the length of the array is 0, 1, 2, 3, 4, so n is supposed 4, and then what we can do is, and this line basically means 4 minus I. So I was initially 0, so it's 0 minus 1, which is 3, so the length becomes this. Yeah, got it. So basically what happens is, wait, okay, so what actually happens is, so the number, let's ignore this. So the number is 4 because it's the length, and then I is, now it's 0 and 1. So 4 minus 1 is 3, so it will take up to 3, right? Up to third index. Then when I increments, when I increments, then I will become 4 minus 1 minus 1, so it becomes 3 minus 1, sorry, 4 minus 1 3, and 3 minus 1 is 2. So 0 1 2, it will take up to this. And when it becomes 2, when I becomes 2, it does 4 minus 2 is 2, 2 minus 1 is 1, and 0 1, it will take up to this. And this is how, like, this is why we took this thing, right? Hope it makes sense. So now let's go back to our question. Yeah, let's go back to our sorting. So we took this, and now what we can do here is, so we have j in range. So we now have to compare two adjacent elements, right? Let's compare, right? Comparing two adjacent elements, or yeah, elements. So what we can do here is we can give an if statement. We can do if array of j, uh, if array of j is greater than array of j plus 1, then we can perform a swap, right? So the way this swap works is array of j, then we take array of j plus 1, my bad, yeah, and then we just swap this to array j, right? uh, and now we can give this as false, yeah. So we give a boolean value as true, now we can set it as false, and I guess, yeah, this should be it. And then we have to do if sorted, no, if array sorted is true, then if array sorted is true, we have to just break this, right? Uh, we have to break this. We have to break this, and then we have to return the array. Return array. Alright, hope it works. Alright, so now we have to do is, what we have to do is call it here. For example, let's do an unsorted array. Let's give it 5 1 4 uh, 3 2 0, and let's just call it bubble, and let's call it unsorted array. Alright, we have some error here. Okay, I got the error. Yep, yep. So here we go. Oh, Python 3 sorted 143. So it's not sorted yet. Let's see why. Do we have to do this? I don't know. 1432. So 5 went to the last element, but it's uh breaking the loop, you know. So the reason, okay, so the reason it's breaking the loop. Okay, okay, got it. So the issue is here, you see, in line 21, what we did was we are doing the if statement inside the loop, inside the J loop. So we have to move it a little sides. Yeah, we can just cut this break. And as you can see, this is how it works: 0 1 2 3 4 5. So this was bubble sort. Uh, hope this video was helpful.